Good morning, everyone. Hope you guys can hear me. Can you guys confirm once?
Yes.
Okay, great. Thanks for confirming. So let us start the session, guys. So if you guys remember, yesterday we have seen what is Google Cloud Platform, what is data engineering, and the course curriculum also we have seen. And as per the course curriculum, we are going to start with today's our first topic, that is why we need the cloud platform. Okay, so in this one, we are going to understand how people were working 10 years before, how in the cloud people are working now with the help of the cloud platforms in data engineering for an application deployment. Let us try to understand one by one so that you are going to appreciate the technology of the cloud. So let me start with, for example, let us try to consider if a new organization wanted to roll out a new application. Okay, for example, if an organization wanted to roll out a new application, the business comes up with the requirements for the application. The business analyst will gather the information from the business, and he analyzes that information and converts that into a set of high level technical requirements. Then he passes that information to the solution architect. So, whenever you want to roll out a new application, any company, if any company want out to create a new application, the business will be there. The business comes up with a requirement for the application, why they want the application, what purpose they want the application. So all of those requirements for the application, the business comes up with the requirements, and the business analyst will come into the picture. He gathers that information and analyzes and converts into a set of high level technical requirements. He passes that technical information to the solution architect. Now the solution architect will create an architecture diagram to be followed for the application deployment process. Okay, what the solution architect will do? In any company, the solution architect will try to create a solution architectural diagram to be followed for the deployment of this application. This may involve the number of servers required for the application deployment, or the front-end web server, or the back-end web servers, or the load balancers, or the infrastructure requirements. All the infrastructure or hardware required for the application deployment will be mentioned in the architectural diagram. Okay, so what the solution architect will do, sir? The solution architect will design the architecture diagram to be followed, which involve plenty of the infrastructure for this application deployment. Now, who has to focus on the infrastructure now, sir? When you follow a traditional working model, who has to create the infrastructure? Can you guys tell me? Can you guys guess it? Who has to create this infrastructure? Who has to worry about this infrastructure? Can you guys guess it? In a traditional working model? Anyone? In a traditional working model, you have to take care of the infrastructure. Your company, whatever the company they wanted to create an application, that company itself take care of the infrastructure. Because at that point of time, you do not have any cloud platforms. Right. So when you are following a traditional working model, whatever the infrastructure that is required for your application deployment, you need to take care of it with the help of the data center. So all the infrastructure should be available in the data center only. So that is the reason this data center will be having the physical resources. This data center will be having the virtual resources. Who is taking care of this data center? The 24 by 7 electricity of the data center, 24 by 7 water supply, 24 by 7 cooling, and 24 by 7 security personnel. Everything has to be taken care by the company itself. So the company is managing this entire data center. Your company has to manage this data center. So if the infrastructure required by the solution architect, whatever the architecture diagram he has created, if the infrastructure is readily available in the data center, then there is no problem. Okay, so if the infrastructure required for the application deployment is already available in the data center, then there is no problem, sir. But if that infrastructure is not available in the data center, what they have to do, sir? Can anyone guess it again? If the infrastructure required for the application deployment, it is not available in the data center, then what they have to do? If it is not available, they have to purchase it, correct? Right? So if it is not available in the data center, they have to purchase it and deliver it to the data center. Okay, so now the solution architect team will check whether the infrastructure is readily available in the data center or not. If it is already available in the data center, then there is no problem. If it is not available in the data center, then they will purchase it. So for the purchasing purpose, the solution architect team will connect with the procurement team. The procurement team will connect with the vendors team. Now the vendors will take even months, days, weeks, and months for the hardware to be purchased and delivered to the data centers. Okay, what the vendors will do? They will purchase the entire hardware required for the application deployment and they will deliver that hardware to the data center. Okay, so this is what happens, guys. So when you go for a traditional working model, so you have to take care of this headache of infrastructure, that the entire infrastructure has to be available in the data center. Okay, you need to take care of the infrastructure. So now if the infrastructure is not available at the data center, the solution architect will create a request to the procurement team. Procurement team will connect with the vendors team. Now the vendors team will purchase the infrastructure and deliver it to the data center. So this process may take days, weeks, even months also for the hardware to be purchased and delivered to the data center. Once the once the infrastructure is received at the data center, that's where the field engineers will come into the picture. Field engineers will come into the picture and they will take care of the rack and stack mechanism. And then the system admins will come into the picture and they will take care of the initial configuration of the system. And the network admins make all the systems to be available over the network. And storage admins will take care of the storage for all of these servers. And the backup admins configure the backups. Once the entire systems are set up as per the standards, they will be handed over to the application team for the application deployment purpose. Now the application team will deploy their code on top of this entire infrastructure. So this is what happens, guys. Look at here. So that's where your application is running smoothly over the infrastructure that is available in the data center. Okay, so if an organization want out to roll out a new application, the business comes up with the requirement for the application. The business analyst will gather the information and he converts that into a set of high level technical requirements and he passes that information to the solution architect. Now the solution architect will think and he create an architecture diagram to be followed for the application deployment, which involves the infrastructure requirements also. If the infrastructure is already available in the data center, then there is no problem. But if it is not available in the data center, they have to purchase the infrastructure. So that's where the solution architect will create a request to the procurement team. The procurement team connect with the vendors team. The vendors team now will take days, weeks, and even months for the hardware to be purchased and deliver it to the data center. Once the hardware is received at the data center, the field engineers will take care of the rack and stack mechanism. The system admins will take care of the initial configuration of the system. The network admins will take care of the systems to be available over the network. Storage admins will assign the storage to the servers. Backup admins will assign the backup. And now the once the entire the systems are available as per the standards, the application team will deploy the infrastructure. Sorry, deploy the code on top of this infrastructure. Then your application is running and it is live. So this is what happens, guys, in a traditional working model. In a traditional working model, this is what happens. Can you guys guess it? What is the problem with this traditional model? Can anyone tell me any single point also? What is problem with this traditional model? Anyone?
I mean, lot of setup is required, and then the
Correct.
maintenance has to be done.
Correct. So there's a lot of amount of setup and infrastructure details, and it is a time-taking process also. If you can see here, so once a solution architect created a request for the procurement, and procurement team take a lot of time for the application, for the infrastructure needs to be purchased and delivered to the data center. This is all time-taking process. So that is the reason the turnover time varies from weeks to months for the everything to be ready for the application deployment. So that is the reason the traditional model is called as a slow deployment model. It is called as a slow deployment model. It is because the turnover time is actually taking a lot of time for the application deployment. So that is the reason we call it as a slow deployment model. And one more thing is that the overall cost to deploy and maintain this working model is very, very high comparatively. See, look at here, it is a very expensive model. It is because so many teams working on behind the scene and so many infrastructure is required. We need to purchase it, we need to take care of all of these things. 24 by 7 electricity, 24 by 7 water supply, cooling supply, all of these things at the data center. It is a very, very costly process. So that is the reason we call it as a expensive working model. And the next thing is that limited automation. Some aspects can be automated easily, but most of the aspects cannot be automated in the traditional working model. You see here, we are doing the rack and stack cabling. Cabling cannot be automated. And there are few deployment processes like system configurations, assigning the backup. These things cannot be automated. So while some aspects of the infrastructure can be automated, but several steps such as rack and stack cabling and a few deployment procedures cannot be automated. They are manual and very slow. So that is the reason we can call this as a limited automation. And one more problem with this one is that human error. So with the many teams working behind the scene, you see here, we have a procurement team, vendors team, field engineers team, systems team, storage team, backup team, application team. So with so many teams working on so many different tasks, the chances of human error is very high, which leads to the inconsistency in the environment. Which leads to what, sir? Which leads to the inconsistency in the environment. And one more major disadvantage is that wasting the resources. So the underutilization of the compute resources is one of the important biggest drawback for the traditional working model is that you purchase the infrastructure, you may not be using it to 60 to 70% of that infrastructure also. That is what we call as the underutilization of the compute resources, which leads to the wasted resources. Okay, so you see here, it is a slow deployment model. It is expensive model. Limited automation is there. Human error is there, which leads to the inconsistency in the environment and wasted resources. So that's where companies are working with the traditional working model. They were looking for an alternative solution to take care of these infrastructure details because they don't wanted to put a headache of infrastructure maintenance. They don't wanted to manage their own data center. They are looking for an alternative solution. They are looking for an alternative solution. So that's where the cloud platforms came into the picture. So the leading cloud providers are like AWS, Azure, and GCP. What they do is that they provide you the cloud computing services to you so that you don't need to worry about the infrastructure. You don't need to worry about procurement team, field engineer, systems, storage, backup. You don't need to worry about the data center also. Okay, so your procurement team now focus on the develop cloud provider. They don't worry about the data center activities. Okay, now you do not have field engineers. These are all the steps are not there because cloud provider provides you the resources directly to your organization. You can have some DevOps engineer. They will take care of the infrastructure creation in the infrastructure. So as per the solution architect, the DevOps team will create the infrastructure. The application team directly deploy the infrastructure. Now this creation of the infrastructure also hardly 1 or 2 days it will take. They won't take much time also. They don't need to purchase anything. They don't need to deliver it to somewhere anything. They just have to create the resources. Creating one resource hardly take 15 to 20 minutes. Okay, so that is what the cloud platforms do a benefit to us. So you don't worry about the any infrastructure details, any data center maintenance, any field engineers. Now look at here, teams are reduced, data center itself it is not there. We need to focus on this such kind of a model. That's the reason most of the companies are looking towards the cloud platforms. It's because of this particular reason only. They don't need to take care of the infrastructure. That is one of the biggest headache on top of the companies. Now it was removed with help of the cloud platforms. Now if we look at the cloud platforms, can you guys tell me guys, now is it a slow deployment model? When you work with the cloud platforms, you do not have a field engineers? No, 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 no. So now you do not have all of these things. So once the infrastructure is mentioned in the solution architecture diagram, the DevOps team will create the infrastructure and the application team will directly deploy it. So that is the reason it is not a slow deployment model. It is also a faster deployment model compared to the traditional working model when you work with the cloud computing model. When you are working with the cloud computing model, the deployment model will be faster. You can easily deploy it, you can easily faster deploy it, and you can scale up and down also as per your requirement. And one more thing is that it is not expensive. You are not maintaining the data center compared to the data center. Creating the resources in the Google Cloud Platform or any other cloud platform is very less cost. So that is the reason we call it as a less expensive working model. And the automation is also high, guys, because in the cloud platforms, you are going to work with the APIs. So most of the things are done via API, which makes you a lot of automation, which gives you a lot of automation. You can able to most of the things you can able to easily automate it. And you do not have a much teams working on the scene, so that you do not have a human error, which does not leads to the inconsistency in the environment. Now, in the cloud platform, you only create the resources that are required for you. And whenever there is a requirement of high resources, you can scale up. And when there is no requirement of resources, you can scale down. So that is the reason utilization of the resources are very good in the cloud computing models compared to the traditional working model. So that is the reason you do not have a concept of wasted resources also. So when you work with a cloud platform, this is what is one more advantage that you are going to get, guys. When you work with the cloud platforms, So what is the difference here? If you try to understand, when you look at it, traditional systems versus cloud platform, the main difference is that the organization managing its own infrastructure for running their code and application. If an organization managing its own infrastructure to run their application or a code is nothing but a traditional working model. What is meant by infrastructure, sir? If you ask me, it can be a server, it can be a hardware, software, or a networking, or a storage. If an organization managing its own infrastructure to run their code or applications, then we call it as a traditional working model or on-premises working model. In a cloud computing model, there is a cloud provider there. The cloud provider delivers the infrastructure as a service. So you don't need to worry about the infrastructure here. Okay, you don't worry about the infrastructure here. It is because the cloud provider delivers the infrastructure as a service to you so that you focus on the infrastructure and you deploy your application on top of that infrastructure. Okay, so this is the main differences between the on-premises working model as well as cloud computing models. In a simple word, if I have to say, if an organization managing its own infrastructure, then we call it as a on-premises infrastructure as a traditional working model, or a cloud computing is nothing but a, if an organization one cloud provider is providing you the cloud computing services as a infrastructure as a service to you, so that you are utilizing those services for your deployment purpose, building your code and deploying your code and scaling your code for all of those things, then you call it as a cloud computing model. So the example is that, for example, cooking a hot, it's like cooking a food at home. Okay, so if you wanted to cook a food at home, what you do, sir? You need to take care of all the things, right? You need to have a stove, you need to have all the utensils, you need to have the vegetables, you need to have a rice, everything you have to take care of it. So that is what we call as a traditional way of eating food. But when you go for a restaurant, cloud computing is nothing but a restaurant. So when you go for a restaurant, you don't need to worry about all of these details, right? You just order it, everything will be in front of you. You pay only for whatever you eat. You pay only for whatever you eat. Similarly, here also, you pay whatever you eat, but you need to take care of all the details here. Okay, so when you go for a cloud computing, whatever the resources you are utilizing, for that you need to pay the cost. Okay, so this is what is the difference. And with a simple example, if you are going for a traditional working model, you need to take care of all the infrastructure for your applications. In a cloud computing model, the cloud provider will take care of the infrastructure on behalf of you, and using that infrastructure, you are going to take care of the building. Sorry, you are going to deploy your applications and scale your applications in the cloud platforms. So this is what is the main difference, and this is why we need the cloud platforms, guys. This is the reason most of the companies are looking towards the cloud platforms. Cloud is the era, guys. Cloud is the next future. So we do not have anything. Cloud is the next future. Okay, yeah. Anyone have any questions on this topic? If anyone have any questions. Okay, I see no one is having any questions. Let me go to the next topic, guys. So I think we have covered what is Google Cloud Platform yesterday. So let us recap one more time. A Google Cloud Platform is one of the leading cloud provider. As we are just talking about the cloud computing, one of such cloud platform or one of such cloud provider is a Google Cloud Platform. Now, what the Google Cloud Platform will do is that it is similar to the all other cloud platforms itself. They provide you the cloud computing services. Okay, they provide you the cloud computing services. These services are very useful for the organizations to build, deploy, and scale the applications and services in the cloud platforms. Okay, so a Google Cloud Platform is one of the leading cloud provider, provides you the cloud computing services. These services are very useful for the organizations to build, deploy, and scale and applications and services in the cloud. These services are highly reliable, secure, and scalable infrastructure that enables the businesses to leverage the Google's global network and data center. And these are the services that are provided by the Google Cloud Platform: compute services, identity and security services, management tools, network services, big data services, storage and database services, machine learning services. So why we learn the GCP? Some people will be having some doubt. Sir, why we need to learn the GCP? Sir, Google Cloud Platform is having a very good community support. And Google is providing you, GCP is providing you the cost effective services. Okay, they are providing you the cost effective services, guys. Compared to the all other cloud platforms, the cost of one resource in the other cloud platforms is very high compared to the GCP. So here in the Google Cloud Platform, for example, if it is GCP, AWS, and Azure, for the same resource, here it is $70, here it is $80, it is $90. The cost of the GCP resources is very less, so that's the reason we call it as a cost-effective resources. And it is providing you the flexible resources, flexible services. The resources can be up and down as per the requirement, so that's the reason we call it as a scaling up and down. Okay, you can increase the resources and decrease the resources as per your need. And it is providing you the trustworthy services, reliable, secured services, fully managed services also, and fast services. The interface for the Google Cloud Platform is also very faster comparatively. Okay, so that is what it is, guys. And Google Cloud Platform is one of the market leader, and good industry adaptation is there, guys. The small companies, the MNC companies, the large companies, the product-based companies started using the GCP already. I am telling you, there can be a plenty of opportunities in the future. Plenty of opportunities. So already, even if today also, if you put your resume, I'm telling you, you get at least 15 calls in within 2 days, because Google Cloud Platform is having a plenty of opportunities. GCP data engineer is having a plenty of opportunities. GCP DevOps as well as GCP data engineer having a plenty of opportunities. You can easily get a job, guys. I'm telling you. If you are putting a little effort, also you can able to get a job easily. And it is providing you the comprehensive service portfolio, and integration and compatibility is there. Machine learning capabilities are also it is providing, global infrastructure, multi-cloud projects, and whoever has done the certification in the GCP has a very good career growth. So all of these things makes most of the companies looking towards a Google Cloud Platform. So that's the reason there are plenty of opportunities. Okay, there are plenty of opportunities. The thing is that there are no skilled persons available. So getting the job is very easy. When you go for AWS and Azure, you have an established market and there is a skilled persons. Competing with the skilled persons for that job is very hard. So people, that's what the people do a mistake that. So if they wanted to get a job, they join Azure and AWS batches. That's fine, but upskilling is fine, but getting the job with these courses is very difficult, guys. I'm telling you, because there is already skilled persons, because these are market is already established. So when the market is already established, like you, someone might have learned these courses already like 3 4 years before, and now they are the skilled persons. When you go for an interview, you are competing with these skilled persons. Okay, when you go for an interview, in interview you are able to see these kind of skilled persons, so the chances of getting the job were very less here, very less chances to get the job. It's because you are competing with the skilled persons. But when you go for the GCP, you have a plenty of opportunities similar to the AWS and Azure, but you do not have a skilled persons here. because GCP itself it is new, itself it is new, and you are now started learning the GCP, and you are competing with the persons who are trained like you. You are competing with the people who are trained like you. So getting the job is very high. Okay, very good chances to get the job. So this is what is a simple thing that keep in mind, guys. So if you wanted to get a job, the important thing is that easily, if you wanted to get into the cloud as a GCP data engineer, it's very easy for with this course. And the career growth for the Google Cloud platform, sorry, growth rate for the Google Cloud platform is very high compared to the AWS and Azure. Also, you see here, guys. Growth rate, you see 54% of the growth rate. That means the company started using the Google Cloud platform even more than the AWS and Azure. Also, it's because of its cost-effective services and reliable services. And Google is offering plenty of roles: GCP data engineer, GCP developer, GCP admin, GCP DevOps, and many other things. And our main agenda is that GCP data engineer, Google Cloud Platform data engineer. And if one wanted to go for the certifications, you can go for Associate Cloud Engineer certification, Professional Data Engineer certification. So that is it, guys. All the introduction related to the Google Cloud Platform is that only. So if anyone have any questions on the GCP, you guys can ask me, guys. Any of the topic related to the course content or anything, you can ask me. You can raise your hand so that I can see you who is asking the question. If anyone have any questions, please raise your hand. Are we good? I did not get you. Sorry. So it actually takes 1 week, guys. The very first basic is that we need to understand the cloud basic. Okay, you must understand the cloud basics. If you don't understand the cloud basics, it's again the thing that even I directly go to the cloud, you may not be able to understand it. So we must understand these cloud basics, such as how to interact with hardly like 4 or 5 days. That's it. After that, we will be getting into the Google Cloud platform. I mean, it is a classes of 45 hours, right? So the first 5 hours you can think of like a theory, but the rest of the things are everything is a development. So that's the reason it is 80% is a practical, guys. Only 20% is theoretical. Okay. Yeah. Yes. Any other questions, anyone? If anyone have any questions, you can ask me. So yes, so with this course, whoever is joining for this course, you will be getting the comprehensive material and video recordings also. Okay, so you'll be getting the video recordings as well as the material, and material is already having the resume templates, interview questions, and certification terms. Okay, so you don't need to worry about it. So we all have everything in the one place only. So here we have the interview question, resume templates, interview question, interview introduction for the project 1 and project 2, and data engineering questions, theoretical questions, coding questions, Python coding questions, SQL coding questions, and end-to-end project is also there. Okay, so you have everything here, guys. Anyone have any other questions? Okay, so if you do not have any other questions, I am going to start with our first topic, that is how to interact with the Google Cloud Platform services, how to interact with the GCP. So let us just start it and maybe we will try to complete it today. Okay. So how to interact with the GCP, sir? See, what we wanted to do with the Google Cloud Platform as a data engineer, I want you guys to tell me. Can you guys tell me what we wanted to do with the Google Cloud Platform? Anyone? What do you wanted to do with the Google Cloud Platform as a GCP data engineer? Anyone? Please unmute yourself and try to talk.
Load the data into the cloud.
Correct. Correct. Loading the data, processing the data. Yes. So the main intention we are using the Google Cloud Platform is that we wanted to take care of the data ingestion. Yes. Data processing, data storage. Okay, so all of these things one by one I am going to tell you because we must understand what we wanted to do. Based on that, we will move further. Data processing, data analysis, data visualization, data governance, and some other things like monitoring also. So we wanted to do all of these things, guys. Okay, sir, I wanted to ingest the data into the Google Cloud Platform, or I wanted to store some data, or I wanted to process the data, or analyze the data, visualize the data, governance and monitoring. So if you wanted to take care of all of these activities, we need to interact with the GCP services, yes or no? Can you guys confirm? That means in Google Cloud Platform, we need to interact. So we wanted to do this all of these activities. For that particular purpose, we are going to the Google Cloud Platform. This is GCP. Okay, in Google Cloud Platform, you have a plenty of services. Okay, so the plenty of services such as you have a Google Cloud Storage, you have a BigQuery, you have a data proc, you have a data flow, you have Airflow, we have PubSub, we have Cloud SQL, we have Cloud Functions. So plenty of services are there. So we wanted to do these all of these activities like data engineering activities, we may have to interact with these services, yes or no? Right, guys. So if you wanted to do all of these activities, we need to go to the Google Cloud Platform and we need to interact with these services. So what are the methods are there to interact with these services if you ask me? Sir, we have three major interface methods are there. So when you wanted to ingest the data, store the data, process the data, analyze the data, visualize the data, we may have to interact with the multiple services in the Google Cloud Platform. We may have to create an end-to-end pipeline today, or maybe tomorrow we wanted to take care of the data governance and access control. We may wanted to monitor our pipeline. So if you wanted to do any of the activities, we may wanted to interact with these multiple services. We may have to interact with these multiple services. To interact with these services, sir, we have three interface methods are there. That is, one is Cloud Console. First one is Cloud Console. The next method is Cloud Shell. The third method is that Cloud SDK. So these are the three methods are there if you wanted to interact with these services, guys. So if you ask me, sir, I wanted to interact with these services to do these actions. So we have these methods are there. Okay. So you have a cloud console, you have a cloud shell, you have a cloud SDK to interact with the GCP services. So now let us try to understand what is Cloud Console, what is Cloud Shell, what is Cloud SDK. So for example, let me go to the Google Cloud Platform, sir. So this is my Google Cloud Platform. So if you wanted to go to the Google Cloud Platform, console.cloud.google.com, you go to the console.cloud.google.com. So this is your, so I will tell you in our upcoming classes, maybe tomorrow I will tell you how you can create a project, how to set up the project, how to enable the billing, how to manage the billing, all of those details tomorrow we will see. So look at here. So this is our console home page, guys. So this is what we call as a console. In a console, if you wanted to interact with the services, you are going to interact with the services via visual interface. So this is your graphical user interface. You are going to interact with the service. For example, I wanted to work with BigQuery. So what you are trying to do here, you are visually interacting with these services. If you wanted to create a table, if you wanted to run something, or if you wanted to look at the data sets, all of these things you are going to do it visually. Okay, if you wanted to create a cloud storage bucket also. Sir, I wanted to create a cloud storage bucket. You come here, visually you are going to interact with the services. So that is the reason Cloud Console is a graphical user interface to interact with the GCP services visually. Okay, what is a Cloud Console? So the very first method is that Cloud Console. Okay, the very first method is the console, guys. What is a console? If you ask me, the very first point is that it is a web-based. Right, it is available over the web only. So it is a web-based graphical user interface to interact with the services. So if you wanted to interact with the GCP services, how do you interact with the GCP services here, guys? Can you guys tell me how we are interacting with the GCP services in the console? Visually, we are going to interact with the GCP services. So that is the reason that first method we call it as a console. Console is a web-based graphical user interface to interact with the GCP services visually. So this is what we call as a console, sir. So what we can do with the console, anything can be done with the help of the console, sir. Example, sir, if you wanted to create a bucket, if you wanted to create a tables and a data set comma table in BigQuery, or if you wanted to create a virtual machine, or if you wanted to create some kind of anything. Okay, if you wanted to work with data pro cluster, to work with data pro cluster, so anything if you wanted to do can be done with help of the console. Okay, so this is what is a console, sir. What is a console? A console is a graphical, a web-based graphical user interface to interact with the GCP services. I think I might have already having the diagram. So let me 1 minute, guys. Yeah, I think here we have it. So let me paste it here to save the time. So I have mentioned the same thing here. Look at here, guys. We have a console. A console is a web-based graphical user interface to interact with the GCP services. Okay, 1 minute. I think let me increase the size here. So when I'm increasing the size, I can able to copy it and paste it here easily. Oh, it's the same size. It's coming. Okay, that's fine. So look at here, guys. Console is a graphical user interface, web-based graphical user interface to interact with the GCP services. Okay, so if you wanted to create a bucket, work with a BigQuery, work with virtual machines or clusters, so you can able to do any of these things with the help of the console. Similarly, as I told you, in Google Cloud Platform, we have a second method, that is Cloud Shell is also there. So what is a Cloud Shell, sir? A Cloud Shell is a Linux-based virtual machine. What is a Cloud Shell? If you ask me, sir, it is a Linux-based virtual machine to interact with the GCP services via command line interface. So Cloud Shell is a web-based command line interface to interact with the GCP services via commands. So here we are going to interact with the GCP services via commands, guys. So if you wanted to create a bucket, you use a command. If you wanted to create a data set and table in the BigQuery, you use a command. If you wanted to work with a cluster, you use the commands to interact with those services. So that is the reason. Cloud Shell is one of the Linux-based virtual machine, which is a web-based command line interface to interact with the GCP services via commands. Okay, so this is what is a Cloud Shell, sir. Okay, so this is what is a Cloud Shell. You can do all of these activities via commands here via visual interface here. Okay, similarly we have a Cloud Shell, right? So let me go to the Google Cloud Platform and show you where is the Cloud Shell available. So look at here, guys. So for example, if you go to the Google Cloud Platform, here you have a activate Cloud Shell button is there. Here we have a activate Cloud Shell button. If you click on it, you will be able to see you have the Cloud Shell button opened at the bottom. You see here, guys, it is opening the Cloud Shell at the bottom. Okay, so this is what is a Cloud Shell, guys. Okay, here you are going to interact with the commands ls. So for example, if you wanted to list out the bqls, BigQuery datasets, if you wanted to see, you should be able to see it like this. Okay, so this is how if you wanted to interact with any of the services in the GCP, you can able to interact via commands here for Google Cloud Storage gsutil ls. Okay, so this is how you can able to interact with the multiple services via commands. In our upcoming sessions, we'll learn it more better. This is just to give you an idea that what are the interface methods are there. In our upcoming sessions, we are going to work with every day with these services only. You are going to understand it more better in that way. Okay, now, so this is what is a Cloud Shell, sir. Similarly, we have a one more service, one more interactive method is also there, that is Cloud SDK. You can see here we have a Cloud SDK, which is a local based command line interface. Similar to the Cloud Shell, we have a Cloud SDK, sir, but the Cloud SDK you can install on top of your local machine. You can download the SDK and you can install the SDK on top of the local machine. So that is the reason I am calling it as a local based command line interface. Okay, so from the local machine, if you wanted to interact with the GCP services, we can use commands. Okay, for example, let me guys show you in our upcoming sessions, you are going to install the SDK here. If you wanted to install the SDK, you just click on this one, automatically it will download the SDK and you can just install it automatically. Once the installation is completed, we will connect it to the Google Cloud Platform. Then from the Google, once you install it, this is how it opens. Cloud SDK. Okay, this is how it opens, guys. SDK, which is installed on top of my local machine, sir. Which is installed on top of my location machine. From this Cloud SDK also, we can able to interact with the Google Cloud Platform services. So this is also one more interface method. Okay, so when you wanted to interact with the GCP, total we have three methods are there. One is console, one is Cloud Shell, and one more is Cloud SDK. Cloud Console is a web-based graphical user interface to interact with the services visually. Cloud Shell is a Linux-based virtual machine, and it is a command line interface to interact with the GCP services via commands. Cloud SDK is a local-based command line interface to interact with the GCP services via commands. These commands are same. The commands are same. The only thing is that this is available over the web. This is can be installed and can be downloaded and installed on top of your local machine. So the thing that you can do with the console can be done with a Cloud Shell, can also be done with help of the SDK. Okay, so this is what is the interface methods in the Google Cloud Platform, sir. Okay, even more better we will understand in our upcoming sessions. Okay, this is just to give you an idea that we have a three interface methods. Console I have shown you, Cloud Shell I have shown you, and Cloud SDK also I have shown you. Okay, once you have created your account, I will show you how you can able to install the SDK also, because some of aspects of the SDK also we are going to do it in the Google Cloud Platform. Okay, yeah. Any question, guys? Sorry. Correct. Correct. I will tell you that tomorrow. It's a different for different environments. I'm going to talk about this project, how to create a project, and how to manage the billing, and how to enable the APIs. Tomorrow's is also a very important session, guys. I'm telling you, tomorrow's is a very basic session that if you wanted to work in the Google Cloud Platform, how projects work. Okay, how projects works, how the billing works, how the resources work, which is a very important session tomorrow, which is a very basic session. So tomorrow I'm going to talk about that. Today you got to know that the interface is available. Okay, so with the help of those interfaces, how do we set up the project, how do we set up the billing, and all of those things we will see tomorrow. Okay, yeah. Any other questions, anyone, on the interface methods? Okay. For that, I actually have a node. So these are the common ways to interact with the GCP services. The choice of method depends on your preferences, the requirements, and the type of interaction that you wanted to have it with the GCP resources. So it totally depends on your project requirement, that if they say you have to use the graphical user interface, you use that only. If they say we are using the SDK, you are using that only. It totally depends on it. If you are having a flexibility in terms of using anything, it's your choice that you wanted to use anything. But there are few services in our upcoming sessions you will get to know more better that. So for BigQuery, we will be using the Cloud Console more. Okay, for interacting, for loading the data, we are going to use the Cloud Shell more. So such kind of things will come with an experience. So in our upcoming sessions, when we are actually dealing with the services, you'll get to know. So that's the reason for every service, if you go to the Google Cloud Storage, I will be creating a bucket using the console. I will be creating a bucket using the Cloud Shell, creating interacting with the cloud storage via Cloud Shell, creating a bucket using the Cloud Shell, and giving the assignment for the SDK. So all of these things are there. So we will be interacting with all of these three methods for each and every service wherever it is possible, and that's where you are going to understand it even more better. Okay. Yes, guys. Any other questions? Correct. So third-party tools and APIs are something like, for example, you have a Power BI, or you have a SSIS or a Informatica. If they wanted to interact with those services via APIs, so that is also one more interacting method. So that totally depends on the project requirement. Okay. So for example, you have an application, they wanted to store some backend data into the Google Cloud Platform database. So that is possible. Okay. So that is what we call as a third-party tool. Okay, so we have a, there is a one more interaction method that's not on us, that's on programmatically interacting with the Google Cloud Platform. So interact with the services, like you can use the console, you can use the Cloud Shell, you can use SDK. But the third party tools are something like some application interacting with the GCP. So some application interacting with the GCP via API. So that is what I meant to say, that APIs and third party tools. Okay, so this is a third method. This is, we are not doing it. This is an application programmatically interacting with the GCP services. Okay, yeah. So this is also we will see an application we are going to create it. So how we are going to see it, that is also there. Yeah. Okay. Any other questions, anyone? Correct. I've shown you the growth market. I've shown you the growth also, right? So it's like this. You only tell me that you have introduced one tool like 15 or 10 years before, and you have introduced a one more tool which you have just introduced 3 to 4 years before. Which one will be in the market more? No, it's not about the tool. It's about the cloud platforms I'm talking about. See, for example, AWS and Azure was established. It's because they are already there in the 10 years in the market. Okay, but for the GCP, it is there in the market only from the last 3 to 4 years. So that is the reason. The thing is that getting the job is easy, first thing. And one more thing is that the resources, why it is having a opportunities, we have to understand. Why it is having plenty of opportunities, why the GCP data engineer is having a plenty of opportunities and demand, it's because that even most of the GCP data engineering projects are also moving to the Google Cloud platform. AWS and Azure projects are also moving to the GCP, guys, nowadays. You may not be able to see that because you might have not worked on in GCP, but I am telling you with the community member, I am saying there are few projects from the AWS directly they are moving to the GCP. So this is what we call as a cloud migration. Okay, so that is also happening nowadays. It's because that the GCP is taking over the market. So a tool which is just introduced like 3 to 4 years before, a tool which was 10 years before, they are having just 30. Azure is having just 25% of the market, and AWS is having 35% of the market, 33, 34. But GCP is now within 3 to 4 years, it is now 20% of the market. It's because how do you think that it is 20% of the market? It's because of its own reliable services and cost-effective services and easy interface. And the growth market, you look at it. The growth rate. When I say growth rate, from last year to this year, for the GCP, it is 54% of the people started using it. 54% of the companies are started using it. For AWS, it is 50. For Azure, it is 50, and for AWS, it is 30 plus only 35 something. So the growth rate you have to understand. It's because the growth rate means after few days this becomes 25, this becomes 30 also. Because when you have a growth rate, that is what it becomes, right? So the market share will increase. Okay, so that is how it is happening nowadays, guys. Within just span of 3 to 4 years, no one heard about the GCP in last 3 years, 4 years before. Even most of the people does not know about the GCP, but GCP is having a very good market in the US. Okay, so you may not be able to understand this thing, but this is what is going to be happening, guys. In next 1 year, most of the companies are looking towards the GCP only for filling their opportunities. This is going to be a very good opportunity for you to grab it. Okay, yeah. Any other questions, anyone? So the big Google Cloud Platform, big data is very famous. So I'm not sure whether how many of the people you already know it or not. Actual big data tools, it is actually introduced by the Google Cloud Platform itself. Okay, so if you have to understand it, so when people were facing the problem with the big data, Google Cloud Platform introduced MapReduce. Yes or no? You might have known about the MapReduce, which was one of the very, very uh, you know, parallel processing engine to work with a very large amount of data. Google has introduced the MapReduce. No one knows about the MapReduce earlier because Google has introduced. People are facing with the large working with the large amounts of the data. Google has introduced a MapReduce. Google has introduced the CDFS, uh, Colossus distributed file system. That's where HDFS was developed. We do not have the capability to store large amounts of the data because GCP is very famous for big data. Okay, it's because that it has a large amount of tools which can process a data. So Google has introduced MapReduce, Google has introduced the CDFS, and Google has introduced the data flow, Apache Beam. So these are all the tools are very useful to work with the. These are the cloud native tools of the GCP itself to work with the big data. So if any big data project which is there in other cloud platforms with a very high cost, so if you go for AWS and Azure, you are going to process it them with a computation very highly cost. The cost is very high. But with the big data in Google Cloud Platform, you have a numerous amount of solutions. First thing, numerous, plenty of solutions are available in the big data like Dataproc, Dataflow, Airflow. Plenty of services are there. One more advantage is that it is cost effective. Okay, you have plenty of application, plenty of services available for the big data, and it is cost effective. So that's the reason, most of the companies are, wherever it is data engineering project, they are using the GCP. Okay, so that's how. This is the reason AWS projects are moved to the Google Cloud Platform. Even one of my students is also last batch. One of the students joins, sir. Even we are also moving the data from the AWS to the big data Google Cloud Platform. He only told us. Okay, so that is how it is happening nowadays, guys. Yeah.
Yeah, in my company, they moved to GCP. They just subscribed. So that's the reason I'm
Correct.
taking this course so I can
Correct.
work on that
See,
project.
see, that's how it is happening. See, one of the guy is also telling. So they are actually started using the GCP. So that's what I'm telling you guys. Today it is 10 companies, tomorrow it is 100 companies, day after tomorrow it is 1,000 companies, after that 1 lakh companies. So everything starts with one step, right? So that is where, so I'm telling you, I've been taught almost 30 batches for the GCP data engineering and GCP DevOps. So most of the people already calling me and saying, sir, I got a job easily. One guy told me that, sir, he is my friend only. One guy has got 4 offer letters. There are few people who got, sir, I'm very happy that I got from 9 LPA to I all the way from the 9 LPA, 18 LPA, 17 LPA. I'm easily able to get it. Earlier, even with my technology, I couldn't able to get 11 LPA, 12 LPA also. Okay, so people are getting the multiple offer letters because you have a multiple opportunities. Okay, so that's the main trend, guys. Try to focus on it, and you go and do a lot of research. If you don't want to do the research, just create a dummy resume and put it in the Naukri. If you're getting the 10 calls on Monday itself, you join the course. On Monday, if you are getting the 10 calls, you join the course. If you're not getting the 10 calls, don't worry about the GCP. Assume that the GCP is not exist. If you are getting the 10 calls, then attend this course. That's what I'm saying. Okay, because for sure this course gives you at least 30 interviews. If you are not able to crack one interview also in the out of 30 interviews, it's on you guys. You are not putting the efforts. Okay, so that is what I would say. Because whoever is joining the course, whoever is serious about the course, for sure they will get the job. There's no doubt about it. Okay, yeah, this is it, guys, for today. If anyone have any questions, you can ask me.
When is the next class?
So tomorrow is also having one more demo, and from Monday onwards it is regular sessions. Please start completing your registrations also. From Monday onwards it's regular, same time. Okay, yeah. Okay, guys. Thank you all. Have a great day. We will meet tomorrow at the same time. Yes, please. Okay. Yes, data flow. Yes. Even Google Cloud has also Databricks. Oh, no, 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 no. Don't think like that. Databricks is a third party. Okay? No, no, no. No, no, no. Don't think like that. Databricks itself, it is a. I am a consultant in Databricks. Okay, first thing, I am a consultant in Databricks. Databricks is not related to the any cloud platforms. First thing, okay, it's a tool. Databricks can itself it is work as a standalone first thing, but people don't want it to use it. It's because they don't wanted to create their own resources. First thing, that's the reason they wanted to deploy it on top of any cloud platform. Working with the Databricks in Azure is same as working with the Databricks in AWS is same as working with the Databricks in the GCP. It is same. There isn't any difference. Databricks only uses the cloud storage account. Whether you use GCS as a cloud storage or Azure Blob as a cloud storage or S3 bucket as a cloud storage is same. Okay, so I work at a consultant in Databricks. I worked on UC. I think you might have known about the Databricks UC or not. Unity catalog. I mainly worked on that UC migration. I mean, I was a developer for that UC. Okay, so I'm telling you, working with the Databricks, Azure or AWS or GCP, it is same. There isn't any much difference. And you got one more advantage with the Databricks and GCP is that because Databricks uses the resources, that means the virtual machines in the GCP, the cost of the GCP virtual machine is very less compared to the AWS and Azure. So that is the advantage that you are going to get. So that is the reason when I was creating a solution for Mahindra XUV 700, as well as Techion, one of the recent projects that I have worked for that. And there was one more company, I forgot that. So these are the companies when I was working with them. So they actually deployed their application on top of them. You see here, these are the POC projects I have recently worked on. So Jenny Optical, Techion, CIQ, and M&M. M&M nothing but a Mahindra and Mahindra XUV 700. So when I was working on with these things, we have deployed the Databricks on GCP only. It's because they were looking for a cost-effective solution. So they didn't worry about whether it is on GCP or AWS or anything, but they were looking for a cost-effective solution. We deployed on top of the GCP only. Okay, so that is how it is, guys. Yeah. Okay. So I am a full time at Context. So I work as a solution architect. I am a consultant at Databricks. So I will be working for the solution architecture. You might have, I might have told you solution architect, right? So I am a solution architect for them. So to create the solution. So I don't work on the development, but I will be guiding the team to the development side. So creating a solution and asking them to do the development. So along with this one, both I will be managing. Yes. Yes, please. It's so that's the reason I choose a small company. Okay, I don't worry about whether you work in a Tech Mahindra, you work in a Infosys, you work in a Capgemini, or you work in a Wipro. So they are having a Accenture or something or Deloitte. So they are having a strict rules of not working in other companies. Okay, but that's the reason I don't work with with those companies. I come from a very good background from the Accenture. I worked on Accenture as well. So they do have a restrictions on working with the multiple companies. So that's the reason I resigned in Accenture. I started working in Contact. So Contact is a free environment for me, and it is a growing company. So I help them to grow. That is one thing, and parallelly, I can also work as a consultant. So that's a you can say it's a I mean it's a consultant position that you don't need to worry about, kind of a contract position you can think of. Okay, so that's the company doesn't worry about it whether you work in that or. But when you go for these companies, if you say you are a trainer in the for other institutions, they won't take you. Okay, so that's the reason I don't focus on it. End of the day, everything is same, guys. Working in a project is everywhere it is same. The only thing is that you are working with a branded one, you are not working with a not branded one. The work that you are doing is everywhere same. Okay, so that's the reason. So I choose a small company to work with. Yeah, correct, correct. I'm a corporate trainer also. Whenever I get a time, I'll take a week off and I'll go for corporate training. So two of the companies are I'll be teaching Rakuten. So what I do is that I take a week off or 2 weeks off, and then I'll go to them and teaching 1 week or 2 weeks for the entire GCP deployments and everything. I'm a DevOps engineer, DevOps trainer as well. Okay, yeah. So this is what I do. Yeah. Correct. The thing is that, guys. So the only course, that is possible. So the thing is that if you are having a kind of questions and that you are coming to the classes with those kind of a questions, for sure I'll be able to help you. After the questions, I may be busy, but in the channels, like Telegram or WhatsApp, if you are able to mention a message in the group, I would be able to help you for sure. But the thing is that when you are having these kind of a questions, right, and you are asking in the classes, for sure I'll be able to help you guys. Okay, I can even give you an examples also. I can even tell you where you can find a proper solution also, because the solution architect is someone that you look at the documentation and you create a solution. So I'll tell you how you can better look for the proper solution in our public documentations. Okay, so that is what we do every day. So if you are having such kind of a questions, you can every day ask me a question. I'll be able to help you with that. That's not a problem at all. Even after the course also, if you have still kind of a questions, you can always message me, and so that I'll be able to help you on that. Okay, yeah. And getting the job with this course is very easy. For that, for sure, I would say getting the job is with this course is very easy. Yeah. So it's like this. A Databricks is a company. It's a well known for its own technology that they are working on. So what they do is that the clients connect with the Databricks. The client connect with the Databricks, and Databricks will connect with me. So we are like almost 5 to 7 consultants are there working for the Databricks. Okay, so what we do is that whenever they are having any project, they connect with us, and we will be connecting directly with the clients, and we will get to know their requirements, and based on the requirements, sometimes not only GCP guys, we worked on Azure also, we worked on AWS. I am a multi-cloud developer, so I worked on AWS and Azure as well. So that's not that. So if they are looking for some kind of a solution, we will be building the solution. Okay, the solution, whether it is involving this cloud platform or that cloud platform, but the solution will be built in the Databricks only. Okay, by using the multiple services in the AWS, Azure, and GCP. So that is what we do. Okay, the requirements come to the Databricks only, and Databricks head will connect with us, and based on that we will proceed further. Okay, so that's where they will be assigning a team of data in the Databricks. There will be a developers team will be there. So 2 to 3 developers they will be assigning on top of this particular project, and we will be taking. We don't take much time for the solution building. We usually take 3 to 4 months, hardly 2 months also. Sometimes we have also done 1 month also. Okay, so it totally depends on the requirement. So if they are still happy with that, so they will be getting more projects. So that's what the Databricks is now working, funding with a lot of projects is because of that. There's a plenty of projects are happening, and Databricks itself, it is every day it is developing. So even if you look at it, so even I go for trainings. You don't remember. So because data warehousing with AI is one of the topics that is very good in the database. So we go for training. So they also train us for artificial intelligence with data warehousing. So for better implementing the data warehouse, how do we use the artificial intelligence? Yeah. Okay, so such kind of a things they are actually training us. Okay, that's also happening. So everything goes with the company, and I have my contact company. We have this contact company also have a project from the Databricks, also have a project from the Databricks, also have a project from the Techian, Mahindra, so plenty of. So I work as a solution architect. So for me, I don't need to develop it. For me, I don't need to develop it, so I get some time. But the thing is that when we are building a solution, so we may have to put a lot of effort and taking care of the challenges and taking care of the management, everything. So that's how it works. Yeah. 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 Okay, guys. Thank you all. Have a great day. And we will meet tomorrow at the same time. Bye bye. Thank you all. Thanks for joining today. Have a great day, man. Bye bye.